This cage is specifically built with bars on every side except the front, which is all plexiglass. So when I jump in there and float out 30, 40 yards, I'm going to look like an easy target for these sharks.
The waters around Isla Guadalupe sit roughly 150 miles off the western coast of Mexico's Baja California Peninsula, and they are cold, deep, and exceptionally clear. That clarity is precisely why researchers and divers come here. Nowhere else in the accessible ocean can you see great white sharks in conditions where visibility extends far enough to study them properly. Their movement patterns, their behavior around each other, their responses to stimuli. On most days, the experience follows a familiar rhythm. Sharks appear from the blue, circle the research cages with the unhurried confidence of animals that have never learned to fear anything, and eventually drift back into the deeper water. It is controlled, it is predictable, and it is about as close to routine as any encounter with one of the ocean's most powerful predators can be. But on one particular dive near Isla Guadalupe, that routine broke down in a way that researchers and marine biologists are still discussing. The moment it broke was not dramatic at first. It was quiet. A single shark swam past the cage, and something on her body caught the attention of the divers inside. What they were looking at would take weeks of expert analysis to partially explain, and the most honest answer that science could provide raised more questions than it resolved. The shark was a large female, estimated at approximately 15 feet in length. In the population that gathers near Guadalupe, that size is not unusual. These are mature, experienced animals, and 15-foot females are a regular presence in the research record. She moved past the cage with the steady, unhurried rhythm typical of sharks in undisturbed water, and the divers were filming her when one of them noticed it. Along her midsection, wrapping around a substantial portion of her body, was a scar. Not the kind of incidental scarring that marine biologists routinely document on great whites, the small cuts and abrasions that accumulate over decades of competitive feeding and territory disputes. This was something categorically different. The wound had healed into a wide, curved mark that traced a near-circular path around her body at the level of her girth. The shape was geometrically distinctive. It was not ragged or irregular the way wounds typically appear after collisions with boats or entanglement with lines. It was smooth and consistent in its curvature, suggesting a single, decisive event rather than prolonged or repeated contact. When the footage was reviewed by marine biologists, the initial question was straightforward. What has a jaw wide enough and powerful enough to produce that mark on a 15-foot shark? Working backward from the geometry of the scar, researchers attempted to estimate the size of whatever had made it. The curve of the wound suggested a jaw spread far beyond what a typical great white shark produces. Even large male great whites, which can reach 17 or 18 feet in length, do not have jaw dimensions consistent with a bite of that circumference on a shark of her size. To encompass the girth of a 15-foot female in a single bite attempt, preliminary estimates suggested the attacker would need to be substantially larger. Some calculations placed the necessary size at between 22 and 25 feet, at the outer edge of what any confirmed record for the species has ever documented. This is where the science becomes genuinely complicated, because what those numbers imply is not impossible, but it sits at the extreme boundary of the known record for Carcharodon carcharias. The largest reliably documented great white sharks reach approximately 20 feet in exceptional cases. Deep Blue, arguably the most famous individual great white shark ever recorded on camera, is estimated at around 20 feet in length. A shark in the 22 to 25-foot range would represent something beyond the documented maximum. Not a different species, not a mythological creature, but simply an individual at the far outer edge of what the species is biologically capable of producing under ideal conditions over a very long lifespan. Great white sharks are believed to be capable of living for approximately 70 years, possibly longer according to some revised estimates, and they continue growing throughout their lives. An animal that reached extreme old age in a productive environment with sufficient prey could theoretically achieve dimensions that no short-lived study program has ever happened to document in the right place at the right time. The ocean is large and research coverage is geographically limited. The absence of a confirmed record is not the same as biological impossibility. The location of the scar on the female's body added another layer of scientific interest. Great white sharks do bite each other, and this is well documented. In competitive feeding situations and in encounters where hierarchy is being established, larger individuals deliver what researchers call bite warnings, controlled contact intended to displace a competitor rather than injure them seriously. These warning bites follow predictable anatomical targeting. They cluster around the head, the gill region, and near the pectoral fins, areas where a bite communicates dominance most efficiently. The scar on this female was not in any of those locations. It was mid-body, centered on her largest girth, which is anatomically consistent with a predatory attack rather than a dominance interaction. Something had attempted to seize her at her widest point, which is exactly how a large predator would approach a prey animal it intended to subdue and consume. The fact that she survived tells its own story. Whatever attacked her either failed to complete the bite with sufficient force or was interrupted before the attack could be pressed further. Either scenario implies a confrontation of extraordinary violence that somehow ended without a fatal outcome for the female. Mating behavior was considered and largely set aside as an explanation. Male great white sharks do bite females during courtship, and this leaves marks. But mating bites are anatomically distinctive. They tend to be located near the pectoral fins. They are shallower than predatory wounds, and they leave a characteristic pattern that experienced researchers recognize. The scar on this female matched none of those characteristics in shape, location, or apparent depth. Ruling out mating behavior narrowed the explanation set considerably and pushed the analysis back toward predatory interaction as the most scientifically defensible interpretation. The discovery came into sharper focus through a separate but connected body of research on great white shark behavior near Isla Guadalupe. In recent years, researchers tracking individual sharks in the area using acoustic tags and camera systems had documented something unusual in the depth profiles of certain animals. Tag sharks were recorded making rapid descents to depths well below their typical foraging range. Then, the data stopped. In the most studied of these cases, the temperature sensor within the tag registered a sudden spike in ambient warmth consistent with the interior temperature of a large marine animal, suggesting the tag shark had been swallowed by something larger. These events do not produce a body. They do not produce definitive visual evidence. What they produce is a data signature that has one coherent biological interpretation and several uncomfortable implications. Something in the deeper water column near these research sites is large enough, warm enough in its digestive physiology, and sufficiently motivated to pursue and consume juvenile to mid-sized great white sharks. The identity of that something has not been confirmed by direct observation. Around the time the footage of the scarred female was being analyzed, a separate encounter at the same location produced what may be the closest thing to a direct sighting. Divers in research cages reported a sudden and complete change in the behavioral environment of the water around them. Sharks that had been active in the area over the previous hour disappeared. Sea lions that had been visible at the margins withdrew. Fish that had been schooling in the mid-column dispersed. This kind of simultaneous, multi-species behavioral response is documented in marine ecology and has a specific name, predator-induced behavioral cascade. And it occurs when the sensory signals of a very large or dominant predator propagate through a body of water ahead of the animal's physical arrival. The animals that fled were not responding to anything visible. They were responding to chemical signals, pressure wave changes, or low-frequency vibrations that conveyed a message their instincts interpreted unambiguously. What followed, according to the research divers present, was a detection on acoustic equipment of a large mass ascending from approximately 200 feet below the cage platform. The ascent was not passive. It tracked in a direct line rather than the drift pattern that would characterize a neutrally buoyant object moving with current. Direct, purposeful vertical movement in the water column is a behavioral indicator that requires muscular control and navigational intent. As the object rose, a visual observation became briefly possible. A tail fin was visible in the distance before the animal turned and descended again. The span of the tail, as estimated by the researchers present and later cross-referenced with a scale of nearby reference objects in the footage, was measured at approximately 8 to 9 feet across. A caudal fin of that width belongs to an animal of very substantial length. Great white sharks of 20 feet have tail fins in the range of 5 to 6 feet across. A 9-foot tail implies a body considerably larger than that. The encounter did not produce a clean, frame-perfect photograph of an identified animal with a tape measure alongside it. This does not require invoking an extinct species, an undiscovered organism, or anything outside the documented biological range of Carcharodon carcharias. It requires accepting that the documented biological range may not represent the actual biological limit of the species, and that decades of surface-focused research may have missed individuals spending most of their time at depths that research programs rarely study systematically. The deeper implication of the scarred female story is not really about the size of the animal that attacked her. It is about the state of ocean knowledge in the 21st century. Isla Guadalupe is one of the most intensively studied great white shark aggregation sites in the world. Researchers have been working there for years with increasingly sophisticated equipment. And within that well-studied location, in water clear enough to see a shark from 30 meters away on a good day, something large enough to leave a bite mark of that scale on a 15-foot shark has been present without producing a confirmed identification. The waters around Guadalupe drop to depths of several thousand feet within a short horizontal distance from the research zone. Everything that happens below a few hundred feet is essentially invisible to current research methodology without purpose-built deep-water equipment that is not routinely deployed in shark research. What the footage showed, in the end, was not a monster. It was not a creature from outside the known natural world. What it showed was a scar on a living animal that had survived something powerful, and a surrounding body of evidence suggesting that the thing which made that scar was still somewhere in the water column below, doing what large predators do, moving slowly, conserving energy, waiting for conditions that make the next encounter worth the effort. Great white sharks have ruled the surface layers of the ocean for millions of years, and most people understand them as the apex of the marine predator hierarchy. The scarred female near Isla Guadalupe suggests that hierarchy may have one more tier than the textbooks currently describe, populated by individuals that the research record has not yet caught up with, old, large, and patient in the way that only long-lived animals in productive deep water can afford to be.